Suppose some dude is taking a 100-kilometer trip by boat in a river, and so when he's going downstream with the current pushing him, it only takes 2.5 hours, and when he's going upstream with the current pushing against him, it takes 3 hours. How fast is the boat and the current? So first, as we begin, let's define a couple variables. We will let B be the speed of the boat, and we will let C be the speed of the current. So this will allow us to be able to put these pieces together and make a system of equations. Okay, so remember also that distance in general is equal to rate times time. So that would mean that if we divided both sides by t, we would get that the rate is equal to distance over time. So let me put that one in a bubble because we'll use that one also. Okay, so let's move into green now. So when we are going downstream with the current pushing us, we are going faster. So that would mean the boat's rate plus the current must be equal to the distance over the time. And the distance was given as 100, and the time was given as 2.5. Now, I left my calculator at school, so instead of doing this by calculation, I'm going to do a little bit of simplification here that'll make my life easier. So multiply top and bottom by 2. So you get 200 over 5. That's equal to 40. And now let's do the other equation, which would be the one where they're going upstream. So when you're going upstream, it's the boat and the current is pushing against you, slowing you down. And in that circumstance, you would be going 100 kilometers, but over the different time of 3 hours, so slightly longer. So I'm going to do a little bit of extra work here. In the top one, we had the number 40, and in the bottom, we have 100 over 3. But I'm going to change the 40 into a 120 over 3, which is equivalent, but will give me the common denominator. So when I work with my equations, it'll be a little bit easier. Okay, so these two equations can now be used to solve the system. So in the first circumstance, let's take these equations and add them. And when we add those equations, b plus b is 2b, c plus negative c is nothing, and when we take the 100 thirds and add on the 120 thirds, we get 220 thirds. So again, remember, I'm using this number, the obvious number, and then I'm using this non-obvious form of 40, so that way I can add much more easily. Okay, divide both sides by 2. B equals 110 over 3. And let's see, 3 goes into 110, 36 and 2/3 times. So it looks like the speed of the boat is 36 and 2/3 kilometers per hour. If you were using a calculator here, you would be getting 36.6 recurring as your speed. Okay, now a little bit of a cool strategy here is instead of, I don't want to plug a fraction in. It's just a little bit more difficult to work with fractions. So instead of doing that, I'm going to take my two equations and subtract them, almost like a double elimination. Okay, so looking at those equations, we get b minus b is 0, c minus negative c is 2c, and 120 thirds minus 100 thirds is 20 thirds. So therefore, dividing by 2 yields 10 thirds, and that, of course, is 3 1/3 kilometers per hour. So again, you calculator people, this would have been 3.3 recurring for that answer. So the speed of the boat is 36 2/3 kilometers an hour. The speed of the current is 3 1/3 kilometers per hour.